What is math? Some people seem to think that math is some ethereal set of unrelated rules and symbols. In this video, I will explain how the rules of mathematics follow logically from one another, how a new mathematical concept is really just built off of previous foundations. Math is really a set of rules that follows from a simple set of axioms, or a statement that we regard as true, with which we can build the rest of our rules. To start off, we define our basic unit of mathematics as the number 1. Next, we define our first operation, addition. We can define all whole numbers in this way, and from addition we can get all of our digits. 1 plus 1 equals 2, 2 plus 1 equals 3, 3 plus 1 equals 4, and so on until we get to 10. In our number system, the numbers start to repeat after 10. We call this base 10. It doesn't have to be this way, but it's another axiom we use to build our system. To review, so far our entire mathematical system consists of whole numbers that we have found only using addition and the number 1. Next, we define subtraction as the opposite of addition. No new rules are introduced, only the inverse of addition. Now let's build our next mathematical operator, multiplication, from what we already have. We can define 2 times 3 as 0 plus 2 plus 2 plus 2. Any multiplication with whole numbers can be found this way. 98 times 86 is 0 plus 98 plus 98 plus 98 until there are 86 98s. We can build division off of multiplication by defining it as how many times you must multiply a number to equal another number. Notice that there are still no more new rules. Division is based solely on multiplication, which we built off of addition. So to divide 56 by 7, we do 0 plus 7 plus 7 plus 7 and count the 7s until we get 56. In this case, there are 8 7s. Now through the axioms of the number 1, addition, and a predetermined base 10 system, we have created subtraction, multiplication, and division. You can continue to extrapolate these ideas to reach exponentiation, square roots, and all other sorts of mathematical wonders. Advanced mathematical concepts weren't pulled out of thin air, they were built upon previous stepping stones.
Sometimes simple questions are the most complex, such as, what is math? Math is the abstract study of how the structures of systems relate and operate. Or, more romantically, math is often referred to as the language in which the universe is written. Now, like our universe, there are parts we understand well, and parts we still know nothing about. But when your teacher gives you a math problem, he or she is giving you a problem that people already know how to solve. To get a better understanding, let's take a big step back and look at a simple caveman example. And let's say this society has no concept of numbers, but they recognize there can be multiples of things. In math terms, this could be explained as 0, 1, and many. Depending on how such a society is structured, this might work just fine. But what if one day you find a hole near your garden of many carrots? You think a carrot might have been there, but since you still have many, you can't be sure of this. You might decide it's a good idea to find a better way to keep track of your carrots beyond just many. Your first idea might be to draw a line right by each carrot. That way, if you come across a line with no carrot next to it, then you can be certain that there's a missing carrot. But what if someone steals a carrot and erases the line at the same time? To handle this, you might keep a record of these lines inside your cave or hut. But to do this, you need to give names to specific quantities of lines. So you start developing numbers. Now you have a concept of 20 being different from 19. This way, you can count lines, then go out and count carrots, and see if they match. Sure, your system of one line for one item gets tricky when dealing with really large numbers, but since you rarely have to deal with hundreds of thousands of anything, that's more of a problem for later civilizations like us. But what we see here is that math is a method of modeling reality, but yet it departs from reality in just the simplest of calculations. 1 plus 1 equals 2, for example. There is no such thing as 2 in nature. There is just a carrot and another carrot. But because they both exist, we can group them and call it 2. And if we have another instance of that, we would have a carrot, another, and another. Now, math can't exist without human thought, but what it models persists throughout nature. Not every aspect of math is guaranteed to have a real-world equivalent, but it's specifically designed to be identical to reality. Finally, it should be noted that since mathematics is an abstraction, there will be cases where things will work in the abstract, but will make no sense when you try to apply it back to the real world. For example, any child could easily think of a number so large that it's more than all the individual measurable objects in the universe. Now, that number exists and is perfectly sensible in the abstract realm of mathematics, but it still has no meaning or use in the real world.